Hey there, it's time for some more statistics videos because I know your life wouldn't be complete without them, really. All right, so we're going to be moving into chapter 7, which is the normal probability distribution. But first thing we're going to do is deal with just any continuous distribution function, probability distribution function. In particular, we're going to start off with the uniform probability distribution function. So let me take a moment and remind everybody what a uniform distribution is. Hold that thought for a sec. There it is. It's right here in chapter 2. We talk about it. A uniform distribution is when the frequency of each value is roughly the same, i.e. they're evenly spread out. Now, not a lot of things, of course, actually fit a uniform distribution, but one thing that does in particular would be dice. So, for example, if this bar represented 1 and 2 and 3 and 4 and 5 and so on, you'd expect all the bars over time to be roughly the same height, because as long as the die isn't loaded, then no side is more likely than the rest. Okay? All right, so let's go back to chapter 7. Oops, you don't need to see that. There we are. Okay, so a probability density function, aka a PDF, is an equation that you use to compute probabilities of continuous random variables. Now, we've already run into an equation for discrete random variables. Oh, I'm going to go get one of those. Hold on. Poof, there it is. This is section 6.2. So this right here in that blue box, oops, hey, I just scrolled away from it. There it is. That's a formula. It's a formula for computing the probability distribution for a discrete random variable. So it has this thing, but of course we never really needed to use it because we have Excel to do it for us down here. But nevertheless, it had an equation that would compute probabilities for you. So in chapter 7, oops, hey, go away. There we are. So in chapter 7, it's the same idea. We want an equation that will create the probabilities for us, but it's going to be more difficult now because instead of being discrete as they were in chapter 6, they're going to be continuous for pretty much the rest of the course, to be honest. All right, so suppose that you, oops, that's a typo. Suppose the cable repair person could show up at any minute in a 2-hour period, say from 3 p.m. to 5 p.m. Draw the graph of the uniform density function. All right, I'm going to have to go draw a graph, and I will be right back. Hold on. Actually, it occurs to me, I want you to see what I'm doing. I'm working in a program here that I don't expect you to own or anything, but I want you to see what I'm doing. So I have down here 2, 3, 4, 5, 6, and so on. All right, now why did I do that? Well, they said it's in equal time from 3 to 5 p.m. Oopsie, there it is, 3 to 5. So I want to be able to see 3 to 5 in here. Now, the thing about a uniform distribution is that it's going to be a straight line, right? Because if it's uniform, then they're all equally likely. So I'm going to add in a graph here. Now, the kicker is you got to figure out how big it is. So first of all, I'm going to add in x equals 3, just so you guys can see this. I only want it to go from 0 to, I don't know, there it is. And then I'm going to make another copy, but at 5. Oopsie, not 35, 5. Okay, so I want something that's going to connect those lines up, some horizontal line, right? So the question is, how big is it? Well, remember that because these are probabilities, they have to sum up to 1. So I need something that would have a box here that would add up to 1. So I'm going to take 1 and divide it by, now what's the distance between here and here in minutes? Well, between hours 3 and 4, there's 60 minutes. 4 and 5 is 60 minutes. So that would give you 120 minutes total. So it's 1 over 120. Oops, and it's y. Wrong kind of function. There it is. All right, see how small that is? It's really tiny. We need to go down here and make it so that I can see down that, which is 0.02. Let's see how that. There we go. All right, hold on one second. Let me change these. There it is. It took me a couple minutes, but there's the uniform distribution. So every minute from 3 to 5 is equally likely, and the height of this is 1 over 120 because there's 120 minutes inside there between 3 and 5. All right? All right, so let me copy and paste this, and then I'll see you here for the next tutorial.